At long last, we've reached the end of section 2.6 on exponential notation. This is the third day we're doing this. It's the last day, and it's tough. This is again one of the hardest parts of the entire course. So good luck and watch the video twice, or come and talk to me. We're going to learn about rational exponents. Now, what does rational mean? When you heard the word rational number, you should remember from a little earlier in this course, a rational number is a number that can be expressed as a fraction. So that's exactly what we're looking at here. We're looking at exponents, which are fractions. So what do we do when we have exponents, which are fractions? Well, let's do an example here to help us out. If I had 3 to the 1/2 times 3 to the 1/2, how could I simplify that? Well, when you have powers with the same base, you can keep the base the same, and what do you do to the exponents? You add them. So you get 3 to the 1/2 plus 1/2, that's plus 1/2, which is the same as 3 to the 1, or just 3. Okay, great, but it doesn't really tell us what we do with fractional exponents. So let's do something else, and this will help clear it up for us. What's root 3 times root 3? Root 3 times root 3 is the same as root 9, because you can multiply the two radicands together, 3 times 3. And the square root of 9 is 3. In fact, you should be able to go from the question to the answer right here. Root 3 times root 3 is 3. Root 5 times root 5 is 5. Root m times root m is m. It's always like that. Now, if you look, both of these things are equal to 3. This is equal to 3, and this is also equal to 3. So those two things must be equal to each other. And in fact, there's two identical things here and two identical things here being multiplied. So one of those identical things, 3.5, must be equal to the other identical thing, root 3. 3 to the 1/2 power equals root 3. Does that show you what fractional exponents do? Probably not, unless you're really intuitive. But how about if I do this? What if I add that little index right there? What's the index that we don't see but is actually there? There's a little 2 there. Hey, that might help you figure out what a fractional exponent does. Basically, whenever you have a fractional exponent, you're going to have a radical sign, and whatever the number is in the denominator, that is now going to be the index in the radical. It's always going to be like that. Okay? I don't really have a great memory device for this. I think one year we talked about this being like a plant. I can't remember why, like a power plant or something like that. And in a plant, what's below ground is the root. So that's why this root here, it's a second root. I think that's pretty horrible, and please come up with something better to help me out. It's not as good as flipping negative, is it? Alright, so there's two ways to answer these. You should really learn how to do them both. One way is just kind of the straightforward. Well, if it's 27 to the 1/3, that's a fraction. As soon as I see there's a fractional exponent, I know I'm going to have a radical sign. What's the index going to be? Whatever the denominator is. So it's going to be 3 here. It's a cube root. What goes into it? Whatever the base was, 27. So the cube root of 27. What multiplies by itself 3 times to get 27? It's 3. 3 times 3 times 3 equals 27. Now, there's also another way you could do this. A little more difficult to learn, but I think if you get this, it'll save you some time in the long run. 27, how can you write that as a power? Can you write that as 2 to the something exponent? Does 27 equal 2 to the second power, or third power, or fourth power? No, it doesn't. If you go by your powers of 2, it goes 2, 4, 8, 16, 32. You never hit 27. But if you go to the third power, it does equal 27 eventually. 3 to the first power is 3, 3 to the second power is 9, 3 to the third power is 27. So instead of writing 27 here, we could write 3 to the third power, and then that's all raised to the 1/3 power. Can you see what you'll do next? This is a power of a power. When you have a power of a power, what do you do with the two exponents? You multiply them. So you have 3 to the 3 times 1/3. How do you multiply when you have a whole number and a fraction? You turn the whole number into a fraction. So it's the same as 3 over 1. That gives you 3 to the 3 over 3. 3 over 3 is 1. So you end up with just 3. Exactly what we had there. By the way, I forgot to write this, the actual rule. Any number to the 1 over n exponent is equal to the nth root of the base a. Okay, let's do another one. Here we have a fractional exponent of 1/2, so you know you're going to have a radical sign. What's the index going to be? Whatever this bottom number is, 2. You don't need to write the 2 if you don't want to. And inside, 0.49. So all you have to do is find the square root of 0.49. Well, the square root of 49 is 7, but we want to end up with 2 decimal places. So how many decimal places should we have in this answer here? We should have half as many. We should be 0.7, or 0.7 would be our answer. If you want to do it the other way, 0.49 is the same as 0.7 squared. And then we're raising all that to the 1/2. Again, you're going to do power over power, multiply those two things together. 2 times 1/2 is 1, so you're left with 0.7 to the 1 power. Same answer. The cube root, negative 64 to the 1/3 power. First of all, this negative is not impacted by that 1/3, right? It's not in brackets. It's not like this. It's not negative 64 to the 1/3. It's negative 64 to the 1/3. So if you're going to do, you can see there's a 1/3, a fraction, so you know you're going to have a radical sign. But this negative sign sits out front. You're going to slap that negative on at the end of this question. What's the index here? Denominator is 3, so the index is 3. And the base 64 goes inside. What does that equal? That equals negative, still there of course. The cube root of 64, what multiplies by itself 3 times to get 64? 4. Okay, a couple other ways you could do this. One way you could do this, you could see that 64, so I have my negative. Then I see that 64 is the same as 4 cubed. 4 times 4 times 4 is 64. And I raise that to the 1/3. Okay, what does that equal? That equals negative 4. What's 3 times 1/3? 1. So you're finished. But what if you didn't? I mean, that's a great way to do it. But what if you didn't realize that it was 4 cubed? What if you said, hey, 64 is the same as 2 to the 6th power? Because that's true, isn't it? 2, 4, 8, 16, 32, 64. And then I raise that to the 1/3 power. Will it still work? Yes, it will. Because that would give you negative 2 to the 6 times 1/3. That's 6 over 1 times 1/3. 6 times 1 is 6. 1 times 3 is 3. So you end up with the 6 over 3, which is the same as negative 2 squared. That does not mean all of the negative 2 squared. It means 2 squared and slap on a negative. That's negative 4. Exactly the same thing. So it works even if you don't switch it to the easiest base. It'll still work if you switch it to a different base. Okay, 16 over 81 to the 1/4. So I have a fractional exponent. You know it's going to have a radical sign. What's the index going to be? 4. We have 16 over 81 inside. In order to do this, take the 4th root of 16 and also take the 4th root of 81. What multiplies by itself 4 times to get 16? 2. What multiplies by itself 4 times to get 81? 3. We're finished. I'm not going to do this one the other way for time's sake. We'll just move on here. Okay, 100 to the negative 1/2. Okay, you have a flippin' negative and you also have a fraction in the exponent. What should you do first? I find that doing the flippin' negative is easiest. So flippin' negative flips this 100 into the denominator. What's now in the numerator? 1. So it's now 1 over 100. And it's 100 not to the negative 1/2, but to the 1/2 power now. Okay, well, 100 to the 1/2 power, we know that means you're going to have a radical sign. The index is going to be 2. You're going to have 100 inside. So you end up with 1 over 10. The other way you could do it, when you could see that 100 is the same as 10 squared, and that's raised to the negative 1/2 power. You have power over power here. What's 2 times negative 1/2? Negative 1. 10 to the negative 1, that's a flippin' negative. You get 1/10. Here's a weird one. 2 to the x power times 16 to the x power, all divided by 1/2 to the x power. Okay, we want to switch these so they all have the same base. See what base they could all have? They could all have a base of 2. So the first one already has a base of 2. Keep it. 2 to the x power. The next one, 16 is the same as 2 to the what? 2 to the 4th, that's what 16 equals, 2, 4, 8, 16, 2 to the 4th, and that's raised to the x power. On the bottom, 2 to the what equals 1/2. That's a bit tricky. To switch 2 into 1/2, it must be a flippin' negative. It must be negative 1, and that's raised to the x power. Okay, you can do power over power here and power over power here. So you get 2 to the x times, what do you do with these powers? You multiply them. So 2 to the x times 2 to the 4x divided by 2 to the, again, multiply those exponents, negative 1 times x is negative 1x. Everything has the same base here. So what does that mean you can do? You can add the exponents on top, so you'd have x, or 1x, I'll put 1x just to help us out. X is the same as 1x, right? Plus 4x, And then you're dividing here, so what do you do with this exponent? You subtract. So it's take away negative 1x equals. Okay, 1x plus 4x is 5x. Take away negative 1x. That's kind of like plus positive. So 5x plus another 1x is 6x. Great answer. Not quite done yet, because you could also look at this 2 to the 6x as 2 to the 6 to the x power. And what is 2 to the 6? 2 to the 6 is 2, 4, 8, 16, 32, 64. So we're left with 64 to the x power. Is this hard or what? This is really, really difficult. I swear if I gave this to my grade 12 students this year, a lot of them would be struggling big time. So as I said, don't despair. This is very, very likely the hardest thing in the whole course. Guess what we're going to do now? Make it harder! Okay, so now we have fractions that don't have a numerator of 1. They have a different numerator, 4 and 3 and 2. What are we going to do here? Well, let's look at another example here. If I had 2 to the 1/3 and I raise that to the 4th power. Well, if I do power of a power rule, I would get 2 to the 4/3, wouldn't I? I'd be multiplying these two exponents together. But another way I could think of this is 2 to the 3rd in brackets is the same as what? Well, that's a fractional exponent, so that'd be a radical sign with a 3 out front is the index and a 2 inside, all raised to the 4th power. So these two things must also be equal to each other. So 2 to the 4/3 power is equal to the cube root of 3. You can see that denominator just does the same thing it did before. It becomes the root out front. But now what we do with the 4 is you raise the whole thing to that power. However, there's another way of thinking of this. Instead of doing it this way, what if I did 2 to the 4th power all to the 1/3 power? That's the same again. If I multiply 4 times 1/3, I again get 2 to the 4/3 power. But this time, if I look at this, that equals 2 to the 4th power, and then I'm taking 1/3 of that, the 1/3 power of that. The 1/3 power of that means, in a radical sign, all of that cubed. So if you compare this and this, all I'm showing you here is it doesn't matter if you first of all take the cube root and then raise that to the 4th power, or if you first of all raise it to the 4th power and then take the cube root. You'll usually find that this first one is easier. Why? Because you get a smaller amount first before you raise it to a 4th power. If you raise something to a 4th power, it's going to get very, very big, and it's often hard to figure out what it is as a cube root. A little confusing again, right? Okay, let me write it. A to the m over n power is equal to, okay, remember that n there is going to become your index. Your a, the base, goes inside, and that's all going to be raised to the m power. Or the other way you could think of it is, it's equal to the nth root of a to the m power. In this one, you do the m power first and then take the nth root. In this one, you take the nth root first, then do the m power. It doesn't make a difference. All right, let's try this. So 27 to the 4/3 root. So it's a fraction. I know I'm going to have this. What is my index going to be? The bottom number, 3. 27 goes inside. We can either raise the 27 to the 4th power first, which seems like a really, really bad idea because it's going to become a massive number, or why don't we do it this way? First of all, take the cube root, then raise it to the 4th power. What's the cube root of 27? 3. Raise 3 to the 4th power. That's 3 times 3 times 3 times 3, it's 81. If you want to do it the other way, 27 is the same as 3 cubed. I think we've already talked about that. And we're raising that to the 4/3 power. Okay? 3 times 4/3 is the same as 12 over 3, which is 4. So you get 3 to the 4th power, which is 81. Exactly what we got. Next one. Negative 0.04 to the 3/2 power. Again, this is not in brackets. This negative sits out front. Radical sign. What's our index? 2. That's the bottom number. So we have 0.04 inside, and this is all, don't put the negative in that bracket, this is all cubed. The square root of 0.04, well, the square root of 4 is 2, and there's 2 decimal places in the question, so you want 1 in the answer, so it should be 0.2. Negative 0.2, all cubed. Again, this is not negative 0.2 in brackets, so it's just 0.2 cubed, which is 0.2 times 0.2 times 0.2, which equals 0.008, and slap that negative on. There's your answer. If you're doing it the other way, you would have negative 0.2. 0.4 is the same as 0.2 squared, and then all of that, but not the negative sign, is raised to the 3/2 power. So you end up with negative 2 times 3/2 is 3. So you get negative 0.2 cubed, which is exactly what you get there, negative 0.008. Okay, did you catch that? Things just changed so very, very slightly. Ignore that. We're moving on. 27 over 8 to the negative 2/3 power. Okay, we have a flippin' negative here. So the first thing we want to do is we want to flip this fraction. So it's going to become 8 over 27. It's now to the what? Doesn't mean to flip this fraction, right? The flippin' negative flips the base. It doesn't flip this fraction. So this is still 2/3. Once you flip the base, all that happens to the exponent is that it goes from a negative to a positive. All right, now 2/3. This is a fraction. We know we're going to have a radical sign with 8 to the 27ths inside. What's our index going to be? 3. And once we've done that, what do we do with this, the 2 there? We square this whole thing. So 8 over 27. Take the cube root of 8, which is 2. 2 times 2 times 2 is 8. Take the cube root of 27, which is 3. 3 times 3 times 3 is 27. And then we square all of that. Okay, spread the love here. 2 squared over 3 squared, which equals 4 over 9. Wow, I won't do that one the other way. Hey, here's a weird one. 0.36 to the 1.5. How do we do that? Now we have decimal exponents. Well, the thing to do with that is you need to change that decimal into a fraction. I don't think your book actually has any of these in it, but I like these questions. I think I'll put one on your test, maybe a bonus, who knows. It's good to know. I don't think it's that bad. 1.5, you want to write it as a fraction. You know what 1.5 is as a fraction? 1.5 is the same as, you should know what 0.5 is. 1.5 is a half. We don't want a mixed fraction. We want improper or top heavy. So 1.5 is the same as 3 over 2. Great. So now what we have is 0.36 to the 3 over 2 power. We can do this now. That's the same as, since it's a fraction as exponent, radical sign. 2 goes here. You don't have to write it. 0.36. And once we have that, we're going to cube it. What's the square root of 0.36? 0.6. And then you have to cube 0.6. Might need your calculator for that. If you do that, you'll get 0.216. Another thing I like to do, you don't have to do this, but another thing I like to do is when I have decimals as my base, I often like to put that as a fraction too. Do you know how to do that? If not, this isn't a good method. But if you do, it's a pretty good method. What's 0.36 as a fraction? Well, what place value is that 6 in? Tenths, hundredths. So this is the same as 36 hundredths. 0.36 is the same as 36 hundredths to the 1.5. 36 over 100, I could divide those both by 4. I get 9 over 25, and I'm raising that to the, I guess this should be in brackets, to the 1.5, which we already said is 3 over 2. Okay, now let's do the same thing we just did. Radical sign, 9 over 25 goes in front, inside, sorry. Out front goes the index of 2, and we're going to cube the whole thing. So first of all, take the square root of 9, 3, and take the square root of 25, 5, and cube it. Spread the love. 3 cubed, 3 times 3 times 3 is 27. 5 cubed, 5 times 5 times 5 is 125. These answers look different. They're exactly the same. This is a decimal, this is a fraction. If you divide 27 by 125, you'll get that decimal here. They're both great. You can do either one of them. Personally, I like the bottom one. Can't really explain why I like it more. Alright, the next one. Here's a case where you have two powers with the same base, and you're dividing. What can you do with the exponents in that case? You can subtract. So you have 7 to the 3/8 take away negative 1/8. So that equals 7 to the 3/8 take away negative 1/8 is 7 to the 4/8. Let's put that in lowest terms. 7 to the 1/2. Hey, we're almost done. 7 to the 1/2. That's a fractional exponent. You know you're going to have radical sign. What's the index? 2. And then it's 7. All to the first power. You don't need to put that. There's your answer, root 7. Very similar for the next one, but this time you're multiplying. So when you're multiplying, you have the same base. You can add the exponents. 2/3 plus 1/2. Uh-oh, need to remember how to add fractions. We need common denominators. 2/3 and 1/2 have a common denominator of 6. What do you have to multiply 3 by to get 6? 2. Multiply the top by 2 as well. 2 times 2 is 4. 2 times what equals 6? 3. Multiply the top by 3, you get 3. So you end up with 5 to the 7/6 power. Okay, we know it's going to be a radical sign. 5 goes inside, index is 6, and you have a 7 inside. Now, a lot of people stop here, and you've done a great job if you get to this. But I want you to think about this for a second. Inside, you have 5 times 5 times 5 times 5 times 5 times 5 times 5. 1, 2, 3, 4, 5, 6, 7. Yes. Do you see what you can do? Since this is club 6, you can take something out as long as you have a group of 6 of them. And you do have a group of 6 of them right here. So what happens when you take that group of 6 out? This 5 comes out. It's still club 6, and what's left inside is one more 5. Now, you don't want to have to write out all these 5s. So back here, when you had the 6th root of 5 to the 7th power, you could think of that as the 6th root of 5 to the 6 times another 5 to the 1, right? 5 to the 6 times 5 to the 1 is 5 to the 7th. Oh, here's your group of 6. This can come out, and you get your 5 out front. It just keeps getting more and more complicated, doesn't it? You must be cursing and swearing by now. I'm sorry. Remember, it's the hardest thing in the whole course. Okay, we're going to simplify this. The 4th root of 32 squared. Well, let's start by putting 32 as a power. 32 is the same as 2 to the 5th. 2, 4, 8, 16, 32. Yep, to the 5th raised to the 2nd power. Well, that equals the 4th root of 2 to the power of a power, so we're going to multiply to the 10th power. Okay, let's switch that back into a fraction here. If you switch this radical back into a fractional exponent, we have an exponent that's a fraction. What number goes on the top? Which one goes on the bottom? The bottom number is the one out front, the index, and your top one's the 10. Oh, we can put that in those terms. That's the same as 5 over 2. Now we'll go back to putting this a radical again. So a radical sign, 2 inside, 2 outside is your index, and a 5 inside. Uh-oh, this is another situation where you can simplify. If it helps you picture it, I'll write out all those 2's. 2 times 2 times 2 times 2 times 2. We have 5 2's. This is club 2, isn't it? So every time you got a pair, it can come out. This can come out, this can come out. So what are we left with as our final answer? Well, this 2 comes out. So does this 2 come out. We're going to multiply those together, and we're left with inside one last 2. 2 times 2 is 4, root 2. That's our final answer. Oh, I know. I can hear tears coming from you. Last one, thank God. Root 27. Well, that's the same as root, how can you write 27 as a power? 3 cubed times cube root of 3. Nothing you can do there. Let's switch both of those into fractional exponents. So the first one has a base of 3. The index out here is what? 2. Or sorry, the index is 2, and that goes on the bottom, and the 3 goes out top. In the second one, the base is 3. The index is 3, that goes on the bottom. And what number goes on top? 1. There is no exponent you're raising the whole thing to, which means it's a first power. Okay, you got to add those exponents. So 3 to the 3 halves plus 1/3. Oh, we need to get common denominators again. Common denominator is 6, so you're going to multiply this denominator by 3, multiply that denominator by 3, you get 9, 6, plus, multiply this one by 3 to get 6, multiply this one by 2 to get 6, multiply this one also by 2, so you get 3 to the 11 over 6. It's now time to put this back in radical form. The base is 3, that goes inside, your index is 6, that comes out front, and you have 11 here. I don't want to write out 11 3's, 3 times 3 times 3 times 3. So you got to think here. This is club 6. Can you get 6 of those 3's? Yes, you can get 6 of those 3's. How many will be left over? 5. So this can come out front, those 6 3's, and leave you with 1 3 out front, a 6, and inside still you have 3 to the 5th power. If you want, you can simplify this, because you know what 3 to the 5th power is. Take your calculator if you need to. 3 times 3 times 3 times 3 times 3 is 243. So it's 3 times the 6th root of 243. We made it. I'm sorry. I know this is awful. Just keep your head up and go do something else for a little while, then come back and take another look at it. If you're having troubles with this or not, I still think you're awesome.